You finally did it. You dropped a small fortune on a top-tier PC with a multi-core CPU and 64 gigabytes of RAM. CPU stands for Central Processing Unit, the brain of the computer, and RAM is random access memory, its short-term workspace. With specs like these, you expect every task to finish the exact millisecond you click your mouse. But the actual experience is rarely that clean. You open a web browser with a handful of tabs, load up a standard chat application, and launch a basic text editor. Your system starts to stutter, and those high-end cooling fans sound like a jet engine preparing for takeoff. Decades ago, developers managed to fit entire physics-based video games into a few tiny kilobytes of memory. Today, a blank document in a modern text editor will easily devour hundreds of megabytes. This creates a massive technological mystery. Why does a tool designed for typing raw text requires exponentially more digital resources to function than the entire operating systems that guided early spaceflight? When software feels this slow, it's easy to assume the developers are simply slacking off, releasing sloppy, unoptimized code because they know our modern hard drives have the space to hide it. The truth is that modern development is a highly disciplined, hyper-efficient machine. It's just that making software lightweight is no longer the target being pursued. There is a paradox at the center of the modern tech stack. The industry's survival actually depends on software remaining inefficient. Former Microsoft executive Nathan Myhrvold coined a principle that explains this behavior. Nathan's law states that software is like a gas. It will naturally expand to fill whatever container of memory or storage it is provided. In the early days of computing, physical hardware was the main financial bottleneck. A single megabyte of storage was incredibly expensive, so programmers would spend months meticulously shaving off individual bytes of code to ensure their programs would actually fit on a disk. Today, memory costs pennies, but human labor, the salaries of trained engineers, is the single most expensive part of building technology. Companies realize it's significantly cheaper to launch memory-hungry software in a week than pay top-tier engineers months to optimize it. The massive storage and RAM in a modern PC essentially serve as a digital dumping ground, allowing companies to trade your computer's resources for payroll savings. Because speed to market is the priority, developers rarely build applications from scratch anymore. Instead, they snap together massive, pre-built digital components to get the job done fast. One of the most common examples is a technology called Electron. It is an underlying software framework used to build Populink desktop workspace and chat applications. Electron allows developers to take code written for websites and package it as a desktop app. To make that work, Electron smuggles an entire instance of the Google Chrome web browser engine inside what looks like a simple tool. When you launch a messaging app, your computer is forced to silently boot up a functioning web browser just to display basic text. We get cheap, convenient software instantly, but we pay for it with an immense, invisible taxation on our computer's processing power. The economic incentive to use massive frameworks ripples all the way up to the titans of the global tech industry, a phenomenon known as Andy and Bill's Law. The law is named after two figures who defined the PC era: Andy Grove, the former CEO of hardware giant Intel, and Bill Gates, the founder of Microsoft. Their relationship followed a brutal piece of industry logic. What Andy gives, Bill takes away. Every time Intel manufactured a new CPU that doubled processing speeds, Microsoft would immediately update their operating system with heavy, unoptimized features that completely consumed that new performance gap. If software developers are constantly erasing the speed gains created by hardware manufacturers, does this cycle actually damage the technology industry? In reality, this cycle sustains the entire industry. If software remained lightweight, a 10-year-old laptop would still run modern tasks flawlessly, and consumer hardware sales would stop. Software must become heavier to force the upgrades that fund hardware research and development. In 1995, computer scientist Niklaus Wirth formalized this phenomenon. Wirth's law states that software is slowing down at a much faster rate than hardware is speeding up. While it's easy to blame corporations, we also have to look at our own buying habits. If lightweight software is so desirable, a company releasing perfectly optimized code should theoretically dominate the market. But software optimization is practically invisible. When users are asked to pay for an upgrade, they rarely care about an update that merely promises to be 20% lighter on their battery. Flashy, heavy updates are what actually drive sales. Consumers eagerly hand over money for bloated programs if they boast visible additions like AI integration or 4K capabilities. The current economic structure rewards companies for building bloated features, while actively punishing the financial investment required to make software run efficiently. This creates an inescapable reality. No matter how much money you spend on a future supercomputer, the software of tomorrow will be perfectly, deliberately engineered to make it feel just as sluggish as the machine you own right now. The whirring of a laptop fan represents the global tech economy working exactly as designed, churning through resources to ensure the cycle of hardware and software sales never stops.